For what values of theta is cotan theta equal to tan theta? So I can go to my cotan graph and tan graph. We can see where those two graphs intersect. So they intersect at that point, that point, that point. They intersect at our 45-degree angles here. So in quadrant 1 at 45 degrees, or pi over 4, okay, it's going to intersect. And then every quadrant is going to have an intersection point. So that's 45 first, then we have 135, and then another 45 degrees gives us 225. So we're gonna have repetitions every 45 degrees, or pi over 4. So in this case here, we end up with our theta value. Our theta is equal to, the first location of this is pi over 4, or 45 degrees. And then we're going to repeat itself every period. So n pi over 2. Okay, where n is an integer. Okay, so these are going to give us all the solutions, and it's based on, we can kind of reason through this as well, but we can also see where the slope and the reciprocal slope are going to be equal to each other at 1. The slope equals 1, or y equals 1, and y equals -1, which happens at those points, at those 45-degree coordinates. Example 6 says, what's the domain and range of these functions? So the first function is cosecant x. And basically the domain is going to be based on the fact that we have these asymptotes that restrict the domain. Otherwise, our domain is perfectly fine. And these asymptotes happen every pi radians. So the domain is going to be x is not equal to n pi. Okay, it's going to be based on those asymptotes. It's all real numbers where x is not equal to n pi. The range is going to be based on the y coordinates. We have a min here and a max here. So there's nothing in between 1 and -1. So the range is going to be either y is less than or equal to -1, or y is greater than or equal to +1. And the same thing can be said for secant. So we have our vertex here and here, which establishes our range. So y is less than or equal to -1, or y is greater than or equal to +1. The domain is slightly different because although the repetitions are the same, the intervals are the same. The actual values of these asymptotes are different. So we can write the domain here as x is not equal to pi over 2, and then from pi over 2, every pi radians, we're going to end up with another asymptote. So I'll show that as n pi. For the cotan value, the range is fairly straightforward. It's just like the tan. The range is all real numbers. But the domain is going to be based again on the asymptotes. So we have our asymptotes starting at 0, and we have intervals of pi. So the domain is going to be x is not equal to n pi. Okay, so it'll be the exact same as cosecant. If you take a look at the cosecant graph and the cotan graph, the asymptotes are in the exact same position, so the domain is going to be exactly the same.